Hello, my name is Nivedita Singh, and for my CS410 project, I wanted to cluster different food products available based on the nutritional components, such as how much protein or sugar or carbs that product had. For my project, I decided to use a dataset that was available on Kaggle. It's from the Open Food Facts organization, and the link to the Kaggle data set is down at the very bottom of the README file here, along with an article that helped me kind of decide about the solution to this problem that I was going to take. So I decided to use Gaussian mixture model, or GMM. Based on that article, they talked a lot about how different the data that I was using wasn't labeled, so I needed to find some unsupervised option, and I decided to go with clustering. And then GMM specifically allows you to have clusters that are of different sizes and shapes, and it's also a probabilistic solution, and it gives you the probability of each of the possible options rather than just one deterministic one. I used Python for my solution. A lot of the normal packages such as scikit-learn or stats. I also used Flask because I wanted to have a website component. There's a little bit more detail over here for the project. There is also more information about each of the files and then some of the concepts that I learned for this specific project. In my repo, there is a data directory that has all of the different files, the CSV files that I used. I was unable to upload the full product CSV originally from Kaggle because of how large the data set was, but it is the same exact file from the Kaggle in the link below. There is also a templates directory which has the HTML pages that are very simple that are used for Flask for the web search. And then there's a few other Python files that I'll kind of drill into a little bit more in detail. So similar to on the repo, I have the project on PyCharm that I've been using to code up. So the website.py is the simplest one, so we'll start there. It just contains two functions, the home and the results page, which the home one takes you to the index.html page in templates, and this just has a small search option available. And then same with results. Once the search has been completed and the results are available for the user, the search page is loaded. So once a user enters the search or searches for a product, we use the get results for user function in the healthyingredients.py file, and then load all. We have pre-clustered information, so the clustering doesn't have to happen every single time. And then all the product names, we want to find the similar products. So if I search for apple, maybe like apple pie or apple juice, and I used TF, term frequency inverse document frequency, or TF-IDF, and cosine similarity to calculate the similarity of my product names. And then based on which cluster the product was in, and then the scores that are associated with that, health scores that are associated with that product. So as I said before, I was using the TF-IDF weighting to make sure that for a product name that had a term that was repeated, or certain products that were, or words or terms that were less frequent, I wanted to highlight those to calculate similarity. So I used the TF-IDF vectorizer that's available in sklearn. And then I used a term analyzer instead of just using strings. And then once we get the matrix, the sparse matrix it returns here, we're able to get the indices of which products are similar and then calculate the similarity score on them. I ended up using the linear kernel just because the cosine similarity function part of sklearn was running into memory issues, and this just calculates a simple dot product. And then I return 10, by default 10 similar products, and then get the similar product names, and then we go back up to here where once we have the product names we're able to get which cluster each of the products belongs to. The clustering that happens previously and is saved off into the file happens in the cluster.py file. At the bottom I'm using the Gaussian mixture model, part of sklearn as well. Split my data set into training and test data, and then fitted the model, and then ran the predictions, and then saved off the files along with the cluster labels that the model generated into these CSV files that I can reload and resave to, so I don't have to recluster every single time. And then some of the other functions that are available in here, let's just start from the top. So I used the silhouette scores and the BIC scores to determine the number of clusters that I wanted to use. I've been running for loops for different ranges. At the end I decided I wanted something in this range, but I ran them from 2 to 30 to get different scores to determine the best option. The normalized data, as I was working through this, I realized that my data sets of the different nutritional fields definitely are not normally distributed, so I wanted to use the box-Cox transformation from Python to also help me normalize or transform the data into a normal distribution. Did some analysis on different values and plotted it using matplotlib to kind of understand what the distribution was before and then what the distribution was after. And this data transformed value is also saved into transformed data. The get num zeros, some of the fields or attributes that I was using had large number of zeros, and I wanted to exclude them from the final model. So I'm just calculating what percentage of that column is 0. That's just some processing. The process file takes in the filtered products for the US and tries to kind of, based on the nutritional components that are available, figure out which ones we want to focus on. And I did that based on the normalizations and the zeros to clean it up a little bit. And then ultimately just rerunning some of these at the end to cluster. The other file that we haven't walked through is this UI cluster info. And this, so when the function from the web page is called to return data, we load in all the clustered information, return one data frame for these attributes that we care about. And then for the products that are similarly named, this helps us get to the similarly named product. And then the get cluster means just gets the average health score based on what the UK FSA recommended for that particular product, to kind of help rank some of the healthiness of the clusters. So let me do a demo. So to run this, I saved off the packages that are currently installed for this project into the requirements.txt file. So as I mentioned here in the document, the README, you can just do a pip install for the requirements.txt file, so we don't have to install each one individually. And then to run the code, there's two ways to do it. You can just run the get results for user function directly from the healthy ingredients file. There's no UI component. You would just have to edit this, or you can run it the browser way. So we'll do both ways just for this demo purposes. Okay, so close that. Let's start with just running the healthy ingredients from down here on line 353 here. Let's just save it off for Apple. This is only going to run when it's main. Okay, so healthy ingredients, and then let us run this. So as you can see here, the different products that are similarly named return here. The cluster number is here. Unfortunately, it's harder to see all the other fields that are in here, so it's a little bit easier to do that in the web version. So we will run the website now. So I'm just running on localhost. I don't have it hosted anywhere. So I take the URL and then paste that into a browser. I like using Chrome. Search for Apple and then submit. When you click on submit, it'll do all the analysis behind the scenes, and then it will return the different product names, what the average cluster score is, the energy or which is similar to calories, carbs, sugars, etc. Those were the fields that we used for the model to determine which cluster it belongs to, and then the cluster number, just mostly just so that you know how they clustered. So a lot of these apple sauces in here kind of cluster to the same cluster. The juice and the apple butter are a little bit more, have larger sugar, so they cluster to a different one, and then it looks like apples just as a fruit based on these values cluster to another one. So you can try this out for different products. We can try this for like apple pie, let's say. Submit. And then again, it does cookie. There's a few different cookies or pies, and that's just using the TF, IDF weighted cosine similarity to get the names, and then the different product clusters based on the different nutritional components. And so certain these cookies and pies that have similar ranges of sugar or carbs kind of go to the same one. This looks like this is slightly more sugar. It's not a perfect clustering. I do think that could use a little bit of work to get better, but to do some more feature selection or understanding of which ones work the best. I think that if I had some more time, I would probably put some more effort towards the quality of the clusters that are being generated. You can just go back and continue searching some more. But thank you for watching the video and for this class. And if there's things that don't make sense or don't work, I'd be happy to provide some more input. My email is in here as well. Thank you.